Okay, so starting off with LeetCode question 24, swapping nodes in pairs. So given a linked list, you swap every two adjacent nodes and return its head. But the only problem here is you cannot switch the values of the nodes themselves. They cannot be changed. So 1 and 2 swap, and then 3 and 4 swap. So initial intuition of this is obviously you still need the head node to exist, and you need the head next node to also exist so you can continue, or there has to be a head and a head next to do any swapping. So that'll be our base case. So if head or head dot node, so if the head or head dot next does not exist, we'll just return head. So that's the base case. And then for the algorithm, I'll go ahead and assign, since we know that this 2, no matter what, will be at the beginning of the list, we can set a dummy node to it to automatically return it, because when you return a list, you return it from the first node, and the head node will be pointing to that 2. So we'll do let dummy equal head dot next to just set it to that 2, and wherever it goes, the dummy will follow it. And then we'll also initialize a previous counter with null for now. And then before I assign previous to anything, I can do this while. Let's see, while, okay, so it'll be while head and head dot next. So while we have a head and a head dot next pointer, I will explain why in a second. So while we have a head and while we have a head dot next, that ensures that when previous is moved to head dot next, a head dot next exists. So I'll do if prev. So if prev is no longer null, I'll do prev dot next equal head dot next, because head dot next still exists. And I'll add prev to head. So here's the main part of the algorithm that had me wrapped up for a long time. So it's okay, let next node equal head dot next. So you're assigning, so if this is A, B, and C, you are assigning next node to C essentially, and then you'll do head dot next equals head. So you're going from head dot next, and then this dot next is currently set to 3, or C for the example. You're going to take this and you're going to change it back to this. So head dot next equals head. So you're basically forcing 2 to point back at 1. And then, so you have a pointer from 1 to 2 and 2 to 1, but you need this 1 pointed at this 3 for now. So we'll do head dot next equals, let's see, equals, which you already have set as next node, and then you move head to next node. So head is updated here, and then we run through this process again. So you go ahead and head dot next, we have a 3 and a 4. 3 and 4 are still there. If prev dot next equals head dot next, so previous is moved to the 4. Prev equals head. Well, okay, so yeah, that prev dot next equals head dot next matters because your prev was here. You've got a 2 pointing to the 1, and your head has moved here, and so that prev is how we still connect this 1 to the 4. So this prev dot next equals head dot next. At the end of this first iteration, head equals next node, so head is here. And so prev dot next equals head dot next would bring this 1 to the 4. So you have 2, 1, 4, and all the other connections are gone. And at the end, when all that looped through, you should have a perfect list. So I'll go ahead and return dummy. Run, see if this works, and it works.